Hey, what's going on? It's your boy Algebra, sitting out here in the studio, aka my living room, also known as the place that my wife hasn't gotten home yet. So I get to tell all my corny jokes, and then I gotta go cook dinner. So this is gonna be a pretty quick lesson today. Talking about radicals, and I like the movie Transformers, so I went ahead and stole their catchphrase. It's more than meets the eye. If y'all don't know what I'm talking about, it's because you're not as big of a Transformers fan as I am. It's about to get Optimus Prime in here. Let's do this. All right, so talking about radicals today. And yesterday we talked about simplifying radicals, the basics of a square root. But what I told you yesterday was also that I could change that root. It doesn't necessarily have to be a square. I can do a cube. I can do a fourth. I can change that value to being whatever I want. And so what I'm going to do is I'm going to talk about the square root house first. The square root house has a couple parts. One, it has an interior. And this interior is going to have your actual number. So I'm going to start off with an example that has 32 in it. This is the value that we're going to be dealing with. This 32 on the inside of the radicand itself is going to be the number that needs to be broken apart. It is the base. Home is where the heart is. This is the heart of this radical house. So then you have the actual structure of the radicand itself, the radical house, whatever you want to call it. But then what we did not talk about yesterday, and a couple people have referenced it in conversation, is that I can put an actual number out on the front porch. I'll call this a porch number. It is actually the exponent. Remember yesterday we said that we are actually just undoing exponents. And so when I give you a porch number like this 3, it is giving me a value that is going to be associated with the base. What this problem says, it is called the cube root of 32. So when I say I want to know what the cube root of 32 is, that means I'm going to put this little number out on the porch. That's a 3. It means that I want you to tell me something to the third power equals 32. That's what we're going to try to figure out. So how does this have to change the process that we started off yesterday? Well, it doesn't have to change it very much. The idea yesterday was that we break apart the 32. 8 times 4. I'm going to break that apart a little bit more. 4 times 2. I'm going to keep on breaking it apart until I have all these 2's down here. Remember, since I broke apart the 8, it doesn't exist anymore. So now that I have all of these 2's, what the 3 on the outside says, what that number on the porch says, is that this is how many repeating factors I need to leave the house. We're talking about a square root. We needed groups of 2. We needed pairs. But now that I'm talking about a cube root, I need 3 repeating factors to leave out of the house. I can't go out on a solo mission. I can't go out with just a single buddy. We've got to have 3 people in the car this time if we're going to leave out of the house. So all 3 of these are tied together. The answer for the cube root of 32 is that I have a group of 2's that left the house, but I had 2 left over. Do I have to keep that number on the porch? Absolutely. Because if you take the number off the porch, then you might start to think that you only need pairs. You might start to think that you can leave if you have just a single partner, but you need 3 members to make a group this time. So yesterday, the second part of the conversation was, it doesn't matter if it's a 2, doesn't matter if it's a 3. What if I decide to change the number on the porch as many times as I want? What if I choose to make the porch number something like 7? And because we don't really like breaking apart the big numbers right now, what if I make it x to the 14th and y to the 9th? How would I deal with that? I'm looking for groups of 7. I need 7 x's to leave out of the house. I have 2 groups of 7. Let me show you why. Because 14 divided by 7 is 2. That means 2 groups of x's have left. When I look at the y's, 9 divided by 7 is 1, but there's 2 y's left over. So I had 2 groups of x's leave. I had 1 group of y's leave, but there are still 2 of them left inside the house. And again, you have to keep that 7 on the outside. So if I continue to talk about changing the porch number, I can do that as many different ways as I want to. So giving you one more example, if I said, tell me what you get for the 5th root of 64 x to the 10th y to the 200 power. I was going to make some kind of crazy number inside of there, but I decided to just keep it at 200. So now the question is, I have this 5th root. I have a 64, some x's, some y's. Do I have to do anything different? And the answer is no. Let's treat it like we've always treated it. We're going to break apart the number. I have a 64. Like Nintendo 64, y'all is way too far back for y'all. Y'all don't know nothing about Nintendo 64. I used to play Mario on that bad boy. Couldn't ever figure out how to beat the game though. But I was the bomb at Mario Kart. Mario Kart on Nintendo 64 was my jam. I'm going to break it apart into 8 and 8. They called it Nintendo 64 because of 8-bit. That's way over your head, computer science. Come see me later, Mosley. 2 times 4. Keep on breaking it down. I'm going to do 2 times 4 again. 2, 2. There's another set of 2s. Remember, since I broke apart the 4s and the 8s, they don't exist to me anymore. I'm looking this time not for a pair. Pairs aren't good enough this time. The whole car has to be filled up. I need 5 people in the car this time if we're going to be rolling anywhere. Here is a group of 5 members. I need all 5 of these 2s to leave. But yeah, there's still one left over, and that's okay. He just has to stay home. I don't know what happened to him to make him not cool enough to join the rest of the group, but he's staying at home and the rest of these 2s are going out. It's like homecoming week all over again, you know? What it says is that I have 2. And what to do with those variables again? We said just divide it. 2x squared y, and again, all I need to do is divide it, so it's y to the 40th. And on the inside, there's just a lonely 2 left over. But please, 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 please remember to put that 5 on top. It needs to remain a 5th root question. I feel like everybody feels comfortable with that for the most part. So let's keep it rolling. Let's keep it moving. Let's scroll down a little bit. Let's talk about something different. We said radicals, there's more than meets the eye. We said a radical is the undoer for an exponent. So what if I were to say something like a square root of x is the same thing as x to the 1/2? That was the sound of minds being blown right there. I like did the hand motion and everything. Somebody's mind is exploding. How are you giving me a fraction as an exponent? Well, actually what is taking place is I am taking a radical. It is a way of rewriting an exponent. That's all it is. We're undoing these operations. And so when I say something like x to the 1/2, I'm really telling you it's the square root of x. So if I were to give you something very simple, like the cube root of x, that means I'm really talking about x to the 1/3 power. I'm going to give you one more example of something really straightforward and easy, and then I'm going to ask you to create a rule from it. If I say the 5th root of x to the 3rd power, it really means x to the 3/5. So there must be a rule for us to follow. The porch number, aka how many members of repeating factors do there need to be to leave out of the radical? That porch number is the denominator in an exponent. I don't feel bad about calling it a porch number because there is no professional academic term for that on the outside. The number sitting on the porch is the denominator. So what would the number that's still inside the radical, what is that exponent? Well, that's the numerator. If you look at that last example that I gave you, I said it's x to the 3rd on the inside. Well, that makes sense why it would be 3/5. So the numerator is going to tell you how many of this variable, of this number, do you actually have inside of there. And so it is possible to have an improper fraction. Here we go. What do you get if I said something like the 4th root of x to the 7th? Well, no doubt about it, if you look back at what we just did before we came down this far, you would have told me that I should divide 7 divided by 4, and that would be 1 with 3 left over. Okay? Not doubting it. You guys should feel comfortable about that. No doubt about it. In my mind, I know this is true. But also what I want you to understand is that this is x to the 7/4. And something about these fractions makes me think about mixed numbers. That would be x to the 1 3/4. Or, pause, timeout. X to the times the 4th root of x cubed. They're all the same. It's a big cycle. We can translate this however we want to. But the big idea is that if I give you a radical, that you can change it into an exponent pretty quickly and pretty easily. So another example of something more along those lines. If I give you something that looks like the cube root of 4x squared times the cube root of 2x to the 19th, we should still be able to put those together. They're both cube roots, so that's okay. Works for me. I'm just going to multiply their insides together since they have the matching porch number. Now, if they don't match on the porch, that causes me an issue. That means I have to think a little bit more. But this problem gives me something like the cube root of 8x to the 21, which turns out to be 2x to the 7th. I've got about 30 seconds left in my video. What would you do? You know what? I'm not even going to worry about the 30 seconds. I'm going to make a part 2 to this video, and it's going to show up as soon as Mr. Shelton clicks on the next link.